Greetings everyone, myself Dr. P. Pavan Kumar. In this video, I am going to tell you the physics importance and how the physics transfers from classroom to crafting technology. Here I am going to introduce what is the importance of physics, especially for engineers. And in this one, before physics, what is a science? So we know all science is a collection of facts of the universe. Some facts are experienced by the humans, something like a friction, magnetism, gravity, etc. And some facts are gained by the efforts of research. This science consists of many sections or many branches, which are of botany, geology, chemistry, astronomy, and of course physics, and many more sciences are there. In this, we are going to focus on the importance of physics. So here, physics deals with non-living things, and physics relates to the properties of matter in all its states, and it's also energy, deals with energy in all its forms, and in simple, it deals with nature. So the main aim of the physics is to establish the relation between matter and energy. Simply, it deals with nature. So, but as an engineer, why I should learn physics? Every engineer must question himself or herself that why should I learn physics? Now let's see that. My simplest answer for this is it's a basic science in every field. Or can you construct a building without any building block? No, you can't. Right. So similarly, no field exists without physics is my simplest answer. But is it enough? Definitely not. So let's explore and excite. So first of all, in the classroom, we do study about lasers. But where do we use these lasers? So now let's see that. Printers. So first and foremost application of laser is a printers. We do regularly watch printers, laser printers we do see. Without laser, you cannot do the print very much faster. That we do see, and we can display the keyboard letters by using lasers just because of its high directionality property. And not only that, in future, we are going to charge our mobile phones with lasers. And another thing is to run the CD. To run the CD in a computers, we need to have lasers. So working of CD is possible only with the lasers. And lasers are highly used in case of optical fiber communication. You are able to communicate with a person who is in US or Australia within before a second. Just how is it possible? Your information is transmitting with a velocity of light because of the existence of optical fibers. In the class, we are going to discuss about the optical fiber properties, phenomena, and principles. So laser and optical fibers we are going to learn in the class. And we do study the quantum mechanics in the class, but in a technology, where do we use these quantum mechanics or quantum principles? Let's see. The buzzword nowadays is a quantum computing. So what's the speciality of quantum computing? How do we understand quantum computing? Definitely, we must have a knowledge of quantum mechanics. So quantum computing is a mixture of quantum mechanics or quantum physics with a computer science. Now, that's not only limited to quantum computing. This quantum mechanics is a basic for quantum computing, quantum communication, and quantum materials. So, different fields. So, the quantum is not only related to quantum computing, it's there in communication, it's also there in material science too. And we do see this display. It's a LED screen. Generally, we do have at our homes, classrooms, and everywhere. So it's a simply LED display. But what is the full form of LED? It is a light emitting diode. That's a tiny size. So in case of that, a diode. Again, what is a diode? Diode is a formation or a mix of PN junction or P-type and N-type semiconductors. So ultimately, semiconductor is a basic. In the classroom, we are going to learn about semiconductors. So is only the LED display? No, information, image display, and decoration purpose, we do use these LEDs. Only this display purpose we do use semiconductors? Again, no. The entire communication is rely on these semiconductors. The basics of semiconductors we are going to learn in the class. And transistors we do have, that's a type of semiconductors. And if by seeing this image we understand that it's a solar panel, and this one is a LED light. So what happens here, semiconductor, in both cases semiconductor is a key thing. So when case of solar cell, when light is incident on that semiconductor, that is converted into electricity, or current will be generated from light in case of solar cell. But in case of LED, when we apply a current, light will be generated or light will be produced. But interesting thing is, to get, if you want to convert light to electricity or electricity to light, we do need semiconductors. That's the importance of semiconductors. Those semiconductors we are going to learn in the class. And another one, dielectric materials. So we know that dielectric materials will enhance the capacitance of capacitor. So the dielectric materials we do learn, and here we are going to use this super capacitors. What is the capacitors we know, but what is the next extended one is a super capacitor. What is that super capacitor we are going to see here. And working off this CD, again a magnetic layer is needed where the dielectric materials play a role. And see again magnetic materials. Already in the previous slide we have seen that there is a CD consists of magnetic layer, and not only that limited use, the bullet trains. Have you heard of that bullet trains? They are working on this one, superconducting phenomena. So that superconducting phenomena, we do need superconducting magnets. For that we should have a knowledge on superconductors and magnetic materials. So in the class, we are going to learn the basic principles of that magnetic materials. And not only magnetic and dielectric, we do need to have energy materials and nanomaterials. And here we are going to have a mobile phones and flexible mobile phones, if you are able to see in the image. So energy storage is a key thing that's possible with the nanotechnology or nanomaterials. Again, energy storage is the biggest thing nowadays, especially in case of electrical vehicles. So what are the, and another one, tiny robots, a tiny electronics that's possible with a nanomaterials or nanoelectronics. These are all possible with the different materials. In the classroom, we are going to see the basic principles of this energy and nanomaterials. And it's not only limited to few, whether you take a solar cell, FET, generators, and to make the artificial skin, LED, capacitors, batteries, photodetector, we do need to have these energy and nanomaterials. And let's take a simple example of a mobile phone. This is a rough structure of a mobile phone. This consists of microphone, camera, microelectronics, sensors, batteries, casting materials, RF components, display systems, speakers, sensors, cover glasses. So many components are exist in a small handheld mobile phone. But is all these things are done by a single engineer? Definitely not. So to make that smartphone, we need an optical engineer, we need a design engineer, mechanical engineer, software engineer is needed, battery engineers, electrical engineers, hardware engineers are needed to make this smartphone. So interdisciplinary or multidisciplinary is highly encourageable in nowadays. It's not limited to a single field. You must expand yourself to the other departments where you are interested in. And not only, as I said, it's not only limited to single thing. There are many more applications are there to explore. But any application you choose, the basic thing is physics. So as plus 2 level students, I want to tell you that don't say, oh my God, physics. Again, that physics, don't say that. Don't hesitate to do that. Just say, thank God, again, my physics, because if you show interest, you can do wonders. So any engineer you are, you must be strong in math and physics. So I want to conclude my presentation with a small thing that, have you know, we are all using mobile phones. So your head weights at different angles, as I mentioned. If you put it straight, it's hardly 4 to 5 kgs. As you are go on increasing the bending angle, the weight of head is going to be increased on the neck. That will give you a pain. So that's again a small physics is involved in this example. So finally, winning is not everything, but wanting to win is everything. Right. So, all the best. Thank you very much for the opportunity and all the best for your success and happy engineering. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.